Okay, so we're going to learn today about skeletal formula. So first of all, I'm going to draw a cheeky little molecule here. It's a little molecule of propane. Look at this. Oh, it's taken quite a while. I've aged 50 years in the process of drawing this bloody thing. That took absolutely ages, and this isn't even a big molecule. I'm going to do the skeletal formula next to it. Bap, bap. There you go, it's done.
Nice.
Right? So skeletal formula is used because it speeds up a lot of time when drawing chemical structures. If I show you some more complicated chemical structures on the board here, this is testosterone, that is the chemical of being... And obviously if I was going to draw that full structural, it would probably take me half an hour and it would take up a lot of space on the page. The skeletal formula allows us to convey information in a much more simplified fashion. But how do we do that? It's learning a new language, so we're going to have to learn how this works. So, skeletal formula has two main differences between full structural formula. The first is that we don't show hydrogens joined to carbon. Okay, that's the first thing. And the second thing is you do not draw any carbons. We'll banish them. So, let's see what that would look like. We've got our... Oh, why have you done that? We've got our propane molecule on the left. Let's start off by rubbing out those hydrogens. And we can see that we now have this 3-carbon chain. We have to use our knowledge of organic chemistry to assume that these carbons are CH3, CH2, CH3. You might be wondering how you work that out. We'll get on to that in a bit, but that's the first thing. The next thing is that we don't draw in these carbons, we just draw the bonds. So I'm not going to rub out these carbons, instead I'm just going to draw the bonds above it. So it would look like that. Now obviously that doesn't really work, so what we actually do is we angle them like this so that they fit together. I'm going to redraw that carbon full structural chain angled so that you can see it. It's like that. And there you go. There's the skeletal formula. It's as simple as that. So I'm going to show you a bunch of skeletal formulas now, and I'll show you how you actually read and analyze them. So let's go ratata. This is butane. So if you're wondering what this structure is, we're trying to translate it into full structural. First thing we do is we can count the carbons. So each point in this line is going to be a carbon because each of these are bonds and we haven't drawn the carbons. So we can count them. 1, 2, 3, 4. So it has 4 carbons. So we can draw that full structural now. But the other thing is the hydrogens. Now we have to just assume that whatever else isn't attached to that carbon is a hydrogen. We know that carbon wants 4 bonds, so this carbon must have 3 hydrogens attached to it. This carbon must have 2 hydrogens attached to it. This one must have 2, and if you're more intelligent than any kind of goldfish, you would have worked out that this one has 3 as well. So there you go. Okay, so what about if we have something with other functional groups in, like an oxygen? So for example, let's draw ethanol. I was about to do it skeletal formula instinctively, so I'll do it full structural formula. And you can also see that full structural formula can get quite messy quite quickly because there's so many bonds all over the place. Let's just rub that bad boy out. Goodbye! You're dead. Alright, so this is ethanol, full structural formula. If we want to replicate it in skeletal formula, we've got the bond here between these 2 carbons, and then we have a bond to an oxygen here. And like I said, we don't show the hydrogens attached to carbons, but we do show the hydrogens attached to other elements. So we do show that that's OH. And there we go. That is ethanol. You know, that cheeky little substance that has probably got you in trouble. There you go. So it's quite simple. There are a lot of misconceptions that come up at this stage of skeletal formula, and that is when people are counting carbons. So I'm going to draw a different bunch of alcohols and explain something. So here is a skeletal formula of which alcohol? Propanol. And a lot of people, when they're starting out with skeletal formula, will say that this is butanol, because they'll count the carbons like this: 1, 2, 3, 4. And I can see why you do that. It goes along with everything that we've said in terms of that the carbons are the dots on that line. But let's just draw out this in full structural formula and you'll see why that's wrong. We've got a carbon here, linked to a carbon here, linked to a carbon here, linked to an oxygen here. And then we've got the H, and that's CH2, and that's CH2, whatever. So the bit that you will get a bit confused with is remembering that these are just bonds. Okay, that is just a bond. And if we haven't drawn anything in between, it's a carbon. But if we have drawn something in between, then it's that element. I'll show that again with an ether, which I think might be a good, I can draw it just coming off this O, which is stuck on the side. Here you've drawn an ether, okay, that is COC, like that. Okay, so it's not every single point in a line. It's specifically ones without an element on it. So what I'm going to do now is I'm going to show you a bunch of different functional groups, different structures. I would like you to just work out the skeletal formula for them. All right, so here's the answer. So the first one of those is but2ene. The next one of those is propanone, which looks like that. Then we have cyclohexanol. You don't need a number there because it doesn't matter. And then the last one is 2,2-dimethyl butane. A little bit messy there. Nice. So what I would recommend with skeletal formula is it's not going to get any easier until you do lots of it. A lot of people don't like skeletal formula and they avoid doing it for the rest of their chemistry degrees. If you do that, well, then you're basically buggered. You need to start doing this from day one. As soon as you get onto an A-level chemistry course, you should start doing skeletal formula all the time. You should get used to it. It is the standard way of showing chemicals in real life. You need to get used to that. Even if you don't like drawing full structural formula, I can guarantee you that in the exam your questions will be asked with skeletal formulas like this, and they'll ask you to state the functional groups in this particular molecule, and you'll have no idea what they are because you are used to functional groups in full structural formula, and you'll get a little bit confused. So you do need to learn this. I know it sounds like it's a pain, but honestly it gets easier and it saves you a lot of time in the exam. Like I said, if I'm going to draw something like non-N, it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, non-N. Quick. All right, ta-ta.